My name is Bassam Tabbara. I'm a software architect on the Windows Server team, and I'm primarily responsible for the Dynamic System Initiative. I don't know how much you guys know about this, but I'm going to give you a brief overview of DSI and what we're doing in our efforts towards management in that space. So let's just go ahead and get started. So just to motivate the space a little, I want to talk about kind of why we're doing DSI and what problems we're trying to solve. So IT complexity today is dramatically increasing, as we all know. IT shops are constantly being challenged to do more with less. There's definitely a push for reducing the complexity in their environments, and it's managing their systems, managing across the entire life cycle of distributed systems. Things such as, creating these systems, deploying them, and managing them on an ongoing basis. This graph shows an interesting data point. Almost 70% of all IT budgets is spent on maintaining existing systems. And only 30% is actually left in value creation or creating new opportunities. This was a study that's done by Accenture on behalf of Microsoft. And these challenges are not only for enterprise customers, they're also for small and medium businesses, although they vary. There are different scales, and they kind of change a little bit. These are the same problems, the same money is being spent by a lot of different businesses on maintaining their existing systems. So if you drill down into this and you think, why is 70% of the money IT budget spent on maintaining existing infrastructure? A lot of it is actually in people cost. This data point comes from IDC, and it's basically shows that 60% or more of the IT budgets is actually spent on paying for people that are making sure that they keep the systems up and running, and they do a lot of different tasks that are part of your IT shops today. Even more than downtime, training, software, or hardware. This particular data point is looked at the 5-year total cost of ownership of running in typical IT enterprises. And if you drill down into this a level deeper, you'll see that a lot of it is what these people are doing is actually manual. A lot of the stuff that people do today in terms of maintaining systems and making sure that they're up, in terms of security, doing security management, doing network management, event management, etc. These are all things that are done, for the most part, manually. And even the people that actually have automation scripts, they tend to be very specific to the organization or very specific to the application. And there really isn't much, there's the efficiency of actually doing such tasks is pretty low in most IT enterprises today. This particular data point, again, was done by interviewing 400 different customers with 25 with data centers with 25 servers or more, and we actually asked them about their 3 top line of business applications and about the tasks that they actually do to on a daily basis to maintain these line of business applications. So areas of configuration, storage, and performance. And as you can see, a lot of it, 50% or more in all cases, was all manual. And these are not just Microsoft data centers. These are heterogeneous data centers. Another point to make here is that a lot of these challenges that are being faced by IT shops today, span the entire life cycle of these systems. Most development teams today aren't even aware of their operational environment. They build applications, they throw it over the fence to the ops guys, and they expect it to run. And conversely, same is true in the operations world. Most people don't necessarily know about all the intricate details of the applications and what it means for them to actually run, how to actually deploy them. And so those issues span the entire life cycle of a system, from the point it's being developed to the point that it's being deployed to the ongoing operations of such systems. So I want to draw an analogy to a movement that happened in the manufacturing industry. There's a lot of lessons that could be learned from there that apply here. So in the past, in the manufacturing industry, in the past, excuse me, products have been designed that couldn't be built. They couldn't be manufactured. They could not be produced. Products have been released to manufacturing that could only really be made to work in a model shop where you had highly skilled technicians working on prototypes and making sure that they can actually modify the design at the manufacturing process so they can actually be built. Well, the manufacturing industry, the how easy a product can be manufactured or produced quickly became an important measure of how well a product is designed. And it's such an important measure that the entire industry started focusing on actually how to come up with a set of guidelines and tools to improve this process, the manufacturability process, building products. And so one graph that stands out of the design for manufacturability is the following. So on the x-axis, you see the different stages of a product's life, from conceptualization to design to testing to process planning to the actual production of a system or of a product. And on the y-axis, we see the lifetime product cost. And the red line shows that the red line shows the actual money spent during the actual money that was paid on a product throughout the different phases of its life. And so at the end of the design phase, we see that about 8% of the total product budget has been spent. But those decisions that were made at the design time locked in committed cost 80% of the entire product's throughout its entire life. And so most of the product cost was locked in at the end of a design time. So the manufacturing industry learned from this pretty quickly and thought, well, how can we make sure that we have lower costs for product development, for product manufacturing, and what they had is the production folks sit down with the design folks pretty early on in the design phase, so they can factor in a lot of the manufacturing concerns and create a product that has a quicker and smoother transition to the manufacturing process and lower cost overall, lower life cycle cost overall. Let me give you an example. Today, if I wanted to print a circuit board, my job was to go and figure out I'm designing some piece of, some new circuit board. I can go buy a set of one of many software tools today, and I could use those to actually lay out my circuit board. Those tools have built into them best practices, recommendations, industry standard parts, where I can actually go in there and then design my circuit board. The software will recommend what I need to do in terms of laying it out, reducing the interference. And then the end result of all this is that it is a document that describes my design in enough detail so that it can be actually printed. I can then take this document and I can send it to one of many manufacturing plants, and they will actually, without knowing anything about my design or changing their manufacturing process in any significant way, they can go ahead and print my circuit board. We look at this as a great example of how we should really be thinking about, dealing with software, especially with complicated pieces of distributed software running in enterprises. We're definitely nowhere near the manufacturing process I described, or the example, in terms of circuit boards today in the software industry. And there's a lot of reasons for that. For one, we need to start thinking about how to build more manageable applications, how to factor in the cost of operations, the complexity of operations, very early on in the design phase, so when we were actually building the software. The development teams have to think about the operational capabilities and the operational requirements of their app. Why are they building it? Very, very early on. They need to talk to the operations folks, make sure they capture all the requirements, and do that very early on. The other is that there's definitely a part to be played here in terms of improving our software solutions, whether it's the operating systems, in terms of not just thinking about managing resources in a single box, but thinking from a scope of a distributed system, what it means to manage resources across an enterprise, or to basically expose management facilities or deployment facilities across an enterprise. There's definitely a role to be played by soft development tools in terms of exposing a development model that is about distributed systems, things that run on an enterprise, things that people are having such a hard time deploying and managing these days. And from our management tools, in terms of not just managing, thinking about managing the individual parts, thinking about managing the pieces that run on single machines, but more about a system level management, thinking about managing an entire enterprise or a line of business application that's composed of multiple pieces running on multiple machines. And so for what we need to do is we need to evolve the IT enterprise into a highly efficient production facility, just like that of most production environments today in the manufacturing industry. And that's why we basically started the Dynamic System Initiative, or DSI. DSI, as I said, is an industry-wide industry-wide initiative, basically to simplify and automate how our customers will design, deploy, and operate distributed systems. Let me just take a little brief second, kind of define a distributed system. Basically, any number of software and hardware pieces that come together to serve a larger role. Your mail and collaboration services running in your enterprise, your line of business applications, enterprise resource planning, any of the stuff that you have in any of your data centers today, enterprise data centers, would be considered a distributed system. It's one that's composed of multiple parts running on multiple machines. And it's not just the software pieces, it's also the hardware pieces. You can't really deploy a multi-tier line of business application today without thinking about firewall configurations and network configurations and storage provisioning. Those are all essential parts of an application. So this is a multi-year effort that started with Windows 2003, and one of the products we released, or one of the features of Windows 2003 is what we're calling automated deployment services. That marked the beginning of the DSI roadmap. This is a pretty long roadmap that we're on, and it's a pretty broad initiative that we're trying to accomplish. And it spans multiple products across Microsoft and across the industry in general, working with our partners on this. So it includes I work for the Windows Server team, and so I'm representing the part mostly that's the infrastructure pieces of DSI, are part of Windows Server. But there's also a lot of work that's happening in our dev tools and our developer division in terms of making sure that we have support for DSI and manageability going forward. There's also a large effort, and we work very closely with the people in the management team, people working on MOM and SMS, and the evolution of both, which is System Center, the next major release of our management solution. And while every one of these, this is a phased release, there will be multiple pieces coming along at different stages of the roadmap. The unifying thread that ties them all together and allows us to have an end-to-end integrated solution is what we call the System Definition Model, SDM. And I will talk about the SDM a little later on in this talk. I want to point out, of course, that DSI is definitely an effort too large for Microsoft to accomplish on its own. And so there's definitely lots of room for IHVs and ISV and system integrators to actually leverage this architecture and provide new software and hardware innovations here. And we're definitely working with partners as well in terms of ensuring that we have a heterogeneous story for non-Windows environments as well. So let me give you kind of a high-level view of the architecture of DSI, and I will use this diagram to structure the rest of the discussion. We're kind of coming at this, so let me just explain this diagram first. This is your typical architecture diagram, layer diagram, so I'll start at the bottom and go with the hardware layer. At the bottom, we see the different pieces of hardware that run in your enterprise and in your IT shops. At the bottom right is what we're calling a dynamic data center. I won't be discussing DDC much in this talk, but basically if you will, the one sentencer is that DDC is a set of servers and storage and network devices that come together in a prescribed network architecture that allows us to do more flexible, dynamic allocation and configuration decisions based on business demand. So we can actually allocate storage, create VLANs, provision machines, all very dynamically based on application needs. And it gives us this framework for actually for doing that. I'll point you to a white paper on this, and I don't know how many of you were at WinHack, but we did a great demo of this in WinHack with HP, and we'll continue to do work in this area. So above the hardware is the managed node, and by node I mean a single machine view. This is where I think of things from a perspective of just a single machine running the operating system and running applications. And I will use the term application here to just refer to pieces of software that run on a single box, run on a single machine. And so if you look at a single machine running the operating system and hosting all these applications, that's the view from a managed node. Above that is a view from a managed system. And a system is really a set of software and hardware pieces that come together. And so from a managed system view, a system can be composed of multiple applications running on multiple machines, but it can also include all the routers and load balancers and dedicated storage devices that are part of a larger system. And in the system view, we have a number of services, including some distributed monitoring service and the SDM service, which I will talk about SDM in the section right after this, which enables us to actually have a system level view and do all sorts of management and development and deployment based on the SDM. And then above that, at the top is the management tools, and those are both your traditional local node management tools, remote management tools that are concerned more about managing the parts, the applications, the things that are run on a single machine. And then a new set of system-level management tools that are more concerned about the systems, the multi-tier systems, the things that are running on multiple machines, and giving you a system-level view. And on the right is development tools, and this is where your traditional development tools are about building applications that run on these machines, software pieces that run on machines. But we're also enabling a new breed of development tools that are about building systems that run on multiple machines. So this is kind of the DSI high-level architecture. We're approaching. I mentioned we have a DSI roadmap, and there's a number of things that are going to be that are going to show up at different stages. We're kind of taking a two-pronged approach to this. We're coming at this from the bottom up. We're also coming at this from the top down. So from bottom up, you'll see us working on the dynamic data center. You'll see a lot of work on hardware and making sure we have better hardware for the future, working with our OEMs and others to ensure that. You'll also see us coming from the Windows operating system perspective, thinking about how to write more manageable applications that expose better settings, better tasks, better health and instrumentation, and so which basically tie into the bigger picture. And you'll also see us coming this from top down, basically from a system perspective. And so coming this from what does it mean to actually think about building a system, deploying a system, and managing a system, and also enabling a set of development tools for systems and management tools for systems. And so we're coming at this from both angles. I will kind of discuss both approaches in this talk. I'll start with top-down first. So I'll talk about the SDM and describe all the system-level perspective and how we're using that to do the deployment and management and everything else. And then later on in this talk, I'll talk about the bottom-up approach and talk about our efforts on how to improve the manageability story, how to build better manageable applications on the Windows platform. So let's start with the top-down view. Again, this is from a perspective of a distributed system. So as I said, systems are these entities that are composed of multiple pieces, software and hardware pieces running on one or more machines. Over the last decade, we've seen a big push towards distributed systems, whether it's starting out early in the decade or early on in terms of client-server architectures, moving to N-tier, specifically 3-tier systems. And now we're seeing a lot about service orientation, connected systems. I'm sure you've heard, you had an earful of this at this SAF or at the PDC last week. And so, systems are pretty unique. They're not your typical application. I mean, you think about you take a system. Let's pick one. Amazon.com. Amazon.com came online about 7 years ago. It was deployed. You first saw it when it first came online, about 7 years ago. It hasn't really gone down since. Systems are unlike applications in that You don't just install them and uninstall them and then upgrade a version and do it. They're living entities. They come online. They continue to be evolved as business demands change or as load changes. And there's continuous evolution of these things. Until maybe at some point they go bankrupt or something else happens. But systems are completely different from just applications. Systems are also different in different in terms of how you manage these things, right? There's typically a large number of people working on systems. So we can't think of systems as we think of applications. We have to actually start thinking about new ways of, describing these systems and managing them and developing, describing them, managing them, and deploying them. Systems are very unique, and so we really have to, push the envelope here and think about what it means to actually have a system-level perspective on the world. So let's look at an example. This is your typical, 3-tier e-commerce system, and at the bottom is the data tier, and we see a customer database, and it describes, the fictional system here is AdventureWorks, and they sell adventure products. At the bottom is the customer database with all the AdventureWorks customers. On the bottom right, we see a catalog database, and this has all the catalog information, all the products that AdventureWorks sells. In the middle tier, we see a bunch of business objects, things like the customer data facade to the customer database, some business policy in terms of customer management that are captured in this customer management business object. We see a catalog management and catalog data facade. Your typical, I'm sure everybody has a line of business application that looks something like this with a 3-tier architecture. And on the top, we see the presentation layer, and we see an administrative catalog, both internal and external customers. Those give you a presentation for managing the catalog. And storefront, which is where customers come in and buy products and log in and do all their work. So, diagrams such as this are really the state of the art today when it comes to describing systems. A step better than this would be actually drawing this in Visio. But they're really just drawings. And while they capture all the information about, what are all the different pieces of a system in terms of, oh yeah, we have this database and we have that database and we have those business objects and they communicate, I don't know how, because there's an arrow here. There really isn't much more information about this. Things like security policies, network configurations. Do I really need DCOM port open between, certain two of these business objects? What authentication scheme am I going to use in terms of a database? What messages are exchanged? What is the configuration? What versions of software do I require? What patch level do I need? This is all information that's typically today, if we're lucky, can be captured, is exchanged in email trails, or is somewhere in a Word document somewhere. We don't have a machine interpretable definition of a system. It doesn't exist today. And given that these things are, these big beasts that we're having such a hard time managing, without having a concise definition, a complete concise definition of a system, how do we expect to actually reduce the cost of managing and deploying these systems? And so this is why we came up with the system definition model. In essence, the SDM is basically a modeling language. It's one where you can actually describe or define a system. We typically refer to this as building a blueprint of a system, which is, in a way, a document that describes the entire system, including all the information that's pertinent to the development phases of the system, the deployment phases of a system, and the ongoing management phases of a system. It's a document that is persisted with the system throughout its life cycle until it's decommissioned. From the minute it's started, the developers and the architects started building the system, all the way to until the system is actually decommissioned or it's at its end of life. I'm going to walk you through an illustration here that kind of visually shows how the SDM is used throughout the life cycle of a system, and then I'll talk about some of the details on the SDM and how it's actually used for throughout the life cycle of a system. So starting out in development, a new breed of development tools, like the next version of Visual Studio. If you were at the PDC, you probably saw the Eric Rudder's keynote, and we demoed a design service called Whitehorse, codename Whitehorse, and he mentioned it yesterday at the Q&A session, and basically it's a design surface that lets you build a system based on the SDM model. The underlying model of it is the SDM, and it allows me to describe a system in its entirety. And it's not just the pieces of software, like this is a web application. No, it's this web application. My system is composed, like AdventureWorks, composed of this web application that talks to this database, that talks to the different pieces of my system. And in there, I can capture all sorts of relevant information to both the deployment and the ongoing operations of a system. In the SDM, I can capture the operational capabilities of a system, any resources required, configurations, and requirements on the host environment. And I'll discuss this as we move forward. So the end result of all this is this design service generates an SDM document. We can then use this SDM document to automatically allocate and configure resources when we're deploying the system, when the system first comes to life, or when we're actually changing the scale of the system. We need to add more servers. We need to add more server instances at the front end, at the presentation tier. Because we have all this information, when we know about the configuration of the system, well, we can actually automate the deployment process and do the allocation. And if you're running on a dynamic data center, well, we can actually allocate networks, make sure we have the right VLANs set up. We can actually do storage allocations, storage provisioning, configuration, setting up LUNs. And we can do things like automate bare metal provisioning of servers and making sure everything fits together. And so so this SDM document, this is the same document, hasn't changed, that we use for both the development phases of the life cycle and the deployment phases. Well, we then take the same SDM document, new management tools that are based on the SDM, can read this document, and they can provide you system-level management based on the SDM. They could, instead of letting you manage the sum of the parts, I have 100 machines in my environment, you could actually start thinking about managing systems. This is my line of business application, and here's how it ties to all the machines that are running in my environment and all the software that's running on them. I can do configuration, validation, and all sorts of interesting scenarios are enabled by the information that we've captured out of the system. And I will briefly run into all of these in the next few slides. So we call the first part, you often hear us referring to as design for operations. Eric Rudder was talking about that yesterday in terms of making sure you design a system, not just applications, design systems, with the operations in mind. Making sure you capture all your operational capabilities, your requirements on an environment, your configuration. Make sure you expose good management instrumentation. Those are all important in terms of building good systems that will, in the long run, reduce the cost of management, reduce the total cost of ownership, bring down the 60% of people cost. And then you'll hear us refer to the automatic deployment pieces as the dynamic data center. So let's talk a little about the SDM. So I'm going to run you through the basic constructs that are in the SDM. The most primitive construct is a definition. I create definitions of systems. I can create definitions of resources, endpoints, and relationships as I'll discuss them. And so a definition is basically a declarative statement about a system. And it's an XML. It lives in this document called an SDM document. And it captures basically all the information about that is important to a system. And essentially, it's made up, when I describe systems, I describe a set of resources, whether software or hardware resources. If I'm creating a definition of a system, that's the storefront of AdventureWorks, then I'm typically talking about the files and binaries and registry keys and things that make up that system. If I'm talking about a larger scale system, well, I can typically talk about this system is composed of, software pieces, the storefront, communicating to other things, and hardware pieces. So those are the basic constructs that I use to build systems. I can build systems out of other systems or subsystems. Each has the definition, and I could use these definitions to compose larger systems infinitely. I can also define relationships. Relationships capture meaningful associations between the resources, the endpoints, the subsystems, and resources, endpoints, and subsystems. And so things such as a communication relationship. This system communicates with this other system, or this system is hosted on this other system, or this system has a dependency on this other system. Those are all relationships that I can use to capture meaningful associations between the different pieces of my definition. So typically, these definitions are built by the developers and the architects when they're working on a system. And they could use those. I mean, you could, when you're building a new system, you can create a system definition for it. Or you could use it to describe existing systems. If I have something that's pre-deployed, well, I can actually describe it as well using the SDM. I can define all the pieces that are pre-deployed. I can define the relationships between them and the endpoints. And then management tools and deployment tools can actually help with that definition. And as I said earlier, this is the same definition that is used across both development and deployment and the ongoing operations of a system. And each of these resources, endpoints, and relationships have definitions themselves. And they can appear in the same SDM document as a system or in separate SDM documents. So essentially, by defining a system in terms of as a composable entity made out of other subsystems and resources and endpoints and relationships, I've captured a skeleton of a system, the basic structure. I've defined VentureWorks as kind of the hand-drawn diagram you've set there with a set of configuration on it and all of the real relationships between them. But there's a lot of other information that can be added on top of this skeleton, right? Things such as, kind of management attributes. Events and what events and instrumentation are raised, what tasks can I call, what's the health model, operational policies, things like service level agreements, transaction flow. Those are all things that can be layered on top of this basic structure now that we have it. So I can define all sorts of more meaningful information on top of the SDM. And those could be done by the operations staff as they learn more about their system or as they understand better understanding of a system, by vendors, and by tools themselves as they know more about as their specific uses of certain pieces of their environment or things that apply to certain domains. Well, they can use the SDM as a skeleton for adding more information that's relevant to their domain. The other point here is that our SDM compliant offerings, our development tools, then the platform will come with a pretty extensive set of base software and hardware definitions. It is extensible. There's a base library of definitions that you could use to compose systems, and it's certainly extensible. There's our partners can add, our vendors can add additional definitions if they need to. Things such as web applications and web services, operating systems themselves, different versions of operating systems, servers, storage, all those things are the pieces that you can use to build systems or define systems today. So this is a snapshot of the design surface, design surface that's codenamed the Whitehorse. I know it's probably pretty hard to read in the back, but I'm going to kind of walk you through it and just to kind of explain how we're using this. So this is the SDM model, if you will, for AdventureWorks, the hand-drawn diagram that we saw earlier. You'll see in the top left corner it says AdventureWorks. This is a system. You're looking at a system and all its subsystems. So we see one of the subsystems called Storefront, which is where customers come in and buy products from AdventureWorks. And the Storefront subsystem here is defined as an ASP.NET web application. Each one of these subsystems is a software piece. It's a project that has an associated project in the IDE. If I double-click on storefront, well, I'll go to the code that's behind storefront. I can actually start writing the ASP.NET web code for it. And the design surface does all sorts of really cool things in terms of round-tripping code. The smaller boxes, the smaller blue boxes are endpoints, and they're used to define communications between these subsystems. And the lines represent communication relationships here. And so by looking at this, I can say that storefront communicates with the catalog management subsystem. You'll hear me say subsystem, but I also talk about each of these software pieces. We call them applications as well. And from an SDM perspective, everything is a system definition and resource. But we have very domain-specific names for things that are different layers. In this example, a subsystem and an application are synonymous. And so, if I've defined my system, well, what can I do? Well, this is, for the most part, this looks like a prettier diagram than the hand-drawn one. But there's a lot more information that's actually captured here, including, well, I know about all the protocols that are used for communication between these different applications. I know about the configuration of those protocols. I know about the configuration of the individual applications. The storefront is an ASP. I know it's an ASP.NET web application. Well, in there, I can actually specify the configuration of it. Do I require scripts to be run? What kind of authentication scheme do I expect to run? Is it certificate authentication? Do I want NTLM? That's all information that is very important to the operations staff when they're deploying, and then when they're actually doing ongoing management of this. So that information is all captured in the same SDM model for AdventureWorks. In addition, I can actually specify requirements on the host environment where I would want these pieces to be deployed. So if I had a requirement that said the IIS box where the storefront instances of storefront will be deployed must have session state and SQL Server, that's a requirement. That's a precondition for me to be to run on an IIS box. Well, that information is also captured in this SDM model. So it's not only my configuration, the configuration of my pieces, but it's also my expectations of the environment where I'm going to be hosted that are captured. So I will point out that this is the same SDM model, this is the same SDM document that is used to deploy or create instances of AdventureWorks and all its pieces, but in different environments, whether it's a lab environment, my dev test environment, or a production environment, or in different organizations, and also to different scales. If this is the same SDM document that I use to deploy to 10 machines or 150 machines. We call this is a scale invariant description of a system. So you can think of each of these as a class, and from each of these classes I can create instances at some point. So I'm sure, as we all know, talking about the different software pieces and their configuration is really not enough when it comes to distributed systems, without really discussing what the network configuration is, what the hardware that I'm going to run this system in, and how it's configured, what the security policies are, what the network architecture supports. I've only done part of the job. And so, again, we're looking at a state-of-the-art diagram in terms of describing deployment environments or data centers today. This is a Visio diagram that shows kind of, two firewalls, two physical domains that are separated. There's a hardened servers that it's probably used to host IIS components, things that are web applications and web services. A database server that's, behind the firewall, catalog servers, application services, et cetera, et cetera. And again, there's a lot of information here that's missing. Things such as the configurations of IIS, the configurations of the firewalls, which ports are opened. All information that if you actually ask the right questions and know how to find the right people, you can probably get that information. Or not. Or people might not really know. So again, not surprisingly, we use the SDM, just like we use the SDM to describe the software pieces of a system. We use the SDM to describe all the hardware pieces as well. and the configurations of the servers. There are multiple levels to the SDM, and I will talk about the layering of an SDM. This diagram here is a snapshot of what's called the Logical Infrastructure Designer in Whitehorse. And what it allows you to do is basically describe the set of hosts to applications. So things such as IIS, we'll see on the top left is a hardened IIS server. And things like another IIS server here called used for data services, potentially where I'm hosting web services, middle tier web services. And with each of these, I can describe a configuration. I can say that hardened IIS means that we have a policy, AdventureWorks Data Center has a policy that they do not host web services on their DMZ zone. And they only require certificate authentication. There is no Active Directory running in that zone. And so they only allow certificate authentication. So those are policies of a data center, whether it's security policies or configurations, that are captured in this SDM model. Essentially, we're using the same SDM modeling language that I described to define a system at a different level. This is not necessarily software, application software pieces, but in this case, it's more like server software pieces, IISs and SQLs and database servers and zones and security policies. We also use the same SDM to talk about hardware pieces. It's a modeling language that's used to model things at different levels. And again, this is a diagram that's independent of scale, and I could use this to actually, in the future, there'll be deployment services that will take this diagram and they'll go configure, allocate resources as necessary, and configure IIS and SQL to meet this specification that you've specified here. And so let me briefly talk about the layering. As I said, we could use the SDM to describe. You saw how we described the software pieces, kind of pieces of an application. But you also saw us talk about the application host, the IIS configuration, the hardened IIS, and the security policies that are centered on it. Well, we could use this, again, as I said, to describe network topologies, to describe storage topologies, and to describe the individual pieces of hardware, the hardware. I have a set of compact blades or HP blades that are running, that have this much memory. Those are all things that could be described using the SDM model. Now, it's important for a number of reasons. One is that today we observe there's a separation of concern that exists in most enterprises. We know that different teams are responsible for different pieces of a system. They're all important pieces. They all come together. They all need to come together for us to have a running system. Without the hardware pieces, nothing runs. Without the network architecture, you have a pretty vulnerable enterprise. And so with the SDM and the support for layering, we can actually have different organizations or different teams within an organization work on different pieces. And just as we compose systems out of subsystems and relationships and all those things, well, we can actually layer systems. I can define a system, and I can actually define relationships between different systems. There are different layers, different levels, different logical levels. Here's an example of 4 different layers of AdventureWorks, but there could be others. There could be that we're not limited to a number of layers. It really is up to an organization or up to actually the specific systems that are defined. And so you can think of it as, at any point, starting at the hardware piece, there's a tree of relationships that describe all the pieces going all the way up. So given a piece of hardware, like a server, well, I could describe, it has a definition in the SDM. I know there might be a relationship up to the operating system, Windows, that is running on this hardware. I have a relationship up to all the applications, one of which might be IIS. IIS might be hosting a set of web services. These web services are part of a line of business application, et cetera, et cetera. So you have a pretty complete picture of pretty much everything that is in your data center with very concrete relationships, with very concrete information in terms of what the configuration of each of these are, what it means to deploy them, what it means to manage them. All that information is captured in this SDM store and is managed by an SDM service. And this service will be an essential part of Windows, and it's what we use to capture. It's what management tools use, and what development tools use, and what deployment tools use in terms of deploying and managing and developing these systems. So the other thing to point out is these relationships at any point between layers or within a layer. When I define relationships, I can specify constraints. And those constraints, so the example I used earlier was I need to be hosted on an IIS box that has session state enabled. Well, that's a constraint that I can specify on my host as a software piece. And what it enables is it enables the enforcement of policy across the different organizations, right, across different teams within an organization. So and I'll talk a little more about what we're doing in terms of design time validation and the design for operations. So let's actually jump right into that. Here's a few scenarios that that are enabled by the SDM that I just kind of want to highlight. Today, in the demo we showed for Whitehorse, well, one of the beauties of capturing the information about the deployment environment and the software pieces from a system level perspective, and having all the operational requirements and the layers and the relationships between them, is that early on in the design time phase, I can actually do a validation, or if you will, a logical deployment to an environment. So imagine that my operations folks built an SDM model for their environment. They define the security policies, they define the data zones, they define the security zones, they define all that information using the SDM. While I'm building my application, I could load that information and have that affect how I design my application. If I'm building a ASP.NET web app and I'm relying on using certain security model, well, if my data center where I'm ultimately going to be deployed doesn't support it, excuse me, I'd rather know about that very early on in my design. You know, that could be a flexible decision that's made on behalf of the operations staff, so I could actually ask them to change it. But the last thing I want to do is actually when I get a page over the weekend when they're deploying my app and they tell me it doesn't work. I want to enable this dialogue between the operations staff and the development staff very early on in the design cycle, because it has an immense bearing on how I design my application and how the operations staff do their work. Well, the SDM, because we have all that information, enables that dialogue. And it actually provides the tools and a framework for enforcing it. And so just like you get warnings and compiler errors when you're compiling, in the SDM, when you build an application and you load up its environment and you actually say validate, well, we'll tell you, you know what, you don't meet the requirements of the data center. I'll take questions at the end because I'm actually running a little behind. So you could actually see that today. If you get if you looked at the demo, they showed a great demo of that. I've loaded an environment and I can actually do design time validation across an environment and enable this dialogue between operations and development staff. The other scenarios in terms of deployment, as I said, because I have such rich information about all the different pieces and how they interrelate, well, I can actually deploy a system, a complete system, not just deploy the individual pieces of a system. I can think about instantiating AdventureWorks as a whole to a certain scale in terms of all the different pieces of AdventureWorks. And then, future versions of Windows will actually have deployment services that are not scoped to the individual applications or just applications. I'm sure you're all familiar with Windows Installer and other installation technologies that are all about installing applications. Well, there's going to be a new breed of deployment solutions that are about deploying systems and dealing with all the intricate complexities of deploying such systems across multiple machines. Deployments that may take weeks to complete. And this includes, as I said, the dynamic data center in terms of allocating things that are lower level and doing validation. From an operational perspective, well, there's a lot of scenarios that are enabled by the SDM here as well. One is desired state management. And so if I have such information and I know about my configuration of a data center and I know about the configuration of the pieces and how every piece down to the hardware interrelates, well, I can describe changes to my environment in terms of the SDM. I can decide to say, you know what, we're going to change our mind about the hardened IIS box and we're going to allow NTLM authentication scheme on that box. that is a change that I can pose in terms of the SDM model. And the beauty of that is I can actually validate how it breaks other apps, how it might not break other apps, how if there's any inconsistencies that exist in the entire system, because I have all such rich information. So I can actually do a lot of validation before making committing to a change. Improved monitoring. That's another important thing. I'm sure all of you are familiar with monitoring tools and central monitoring tools that aggregate events from different machines and allow you to look at them in a console and do meaningful tasks with them. But with the SDM, what we enable is that you could use all the rich information in the SDM to provide better monitoring. If somebody pulls a cable, a network cable on one of the machines, well, today I can tell you machine X, first has a nick and one of the ports went down. And that's a very relevant piece of information. But until I tie it to a larger context, I don't know if I'm vulnerable, if my enterprise is vulnerable. I don't know if this is a primary server that has all my customer data on it, or it's some clone of one of my front-end machines and I should ignore. Well, with the SDM, because we've captured all the information about systems, and we've done all the deployment and have all the information about the instance of such systems, well, that's pretty easy information to look up. I could tell you that this machine is the machine that's running Windows 2003, that's hosting IIS, that's hosting 3 web services, one of which is your financial web service, and it's the only one. So your financial system is down. I have that information. That information is all there. And then lastly, because the SDM has such a broad scope that crosses all your enterprise and not just the individual pieces or small parts of it, automation processes are vastly improved. Most automation today is done in scripts. We see a lot of scripts that are done on mostly a machine level. I do RSH, or I connect to a machine and I run a script on the machine. But what we don't see is a lot of automation that's done across purposes, across different parts of an environment. Orchestrations, workflows that are happening across an enterprise that might take weeks to complete. Doing a rolling upgrade in an enterprise is a pretty complicated process that involves many people. It might take weeks, might involve lots of phone calls, there's a workflow process that is involved here. And we're thinking a lot about how to actually enable workflow scenarios based on the SDM, using the SDM as an object model for it. If I've defined all the pieces of my enterprise, imagine that this is now the object model for your enterprise. Each of the objects exposes certain management capabilities. I can call stop on the backup or backup or restore on a database. I can find what other pieces are communicating with this database. I can do a lot of operations based on this object model. It effectively becomes a namespace for management across the enterprise. So our immediate focus is near-term focus. We're thinking a lot about distributed software deployment, whether it's the update services and system management server and the automated deployment services based on the SDM. And we're definitely in the Longhorn timeframe thinking about distributed monitoring and what it means to improve the monitoring information using the SDM and all that work. So let me move on to the bottom-up approach. So if you remember, I talked about a top-down and a bottom-up approach. Top-down was from the perspective of a system, and the bottom-up was from the perspective of a node or an application running on a node. So there's a lot of work actually that's going into Longhorn in terms of improving the manageability of applications. As we know, you can't really build good manageable systems without building good manageable parts of a system or these applications that are running. Today, this is a pretty complicated task. Most management interfaces today are built in separate organizations. There's a dev folks that are working on the application itself, and then if you're lucky, the ISV or the different people have somebody working on management of the management interfaces of the application. And typically, this is something that's duct taped onto the application. It's not part and parcel of it. It's not an important part of it. It's this thing we have to do on the side, like a setup program we do on the side. Only a setup program is more important because you can't really, nobody installs your program without setup. Management is usually an afterthought. People don't necessarily invest in doing management tools because, until they start hearing from customers that it's important, why would they do it? And typically, for me to actually expose management interfaces and build a manageable application, a really well-managed application, I have to learn a set of different technologies and a set of different methodologies. They're not, as a developer, they're not the things that I'm really used to. They're usually yet a different model that I have to learn in order to do this. And today, while there's a lot of tools today that we provide that help us, specifically I talk about the management packs here that help you capture information about the management aspects of your application, and also the great work that happened in the enterprise instrumentation framework that's part of Visual Studio that helps you expose instrumentation. There's actually a lot of room for improvement here. And in Windows, in the Longhorn release, we're thinking how to dramatically improve exposing management or building better managed applications. And there are 3 parts to our approach. One is we're improving the infrastructure. So there'll be dramatically improved infrastructure in terms of, events and instrumentation in general, tasks and settings and configuration. We're making it really easy for developers to expose good management attributes. There's a very simple participatory model where it's a declarative model. You declare your management attributes, and the system takes care of the rest. I'll talk about those in a little bit. And then we have a set of guidelines for what it means to have a manageable application, a good managed application. And this is all, again, part of a design for operations. So this picture kind of shows the 3 things that we're focusing on in Longhorn release. The yellow box here shows your application. So if I was building an application, every application in the Longhorn timeframe has what we're calling the application manifest. And it's basically an XML document that describes all the pieces of my application. So if I'm building an application, and you'll see this in the Whidbey release, it's called the Click Once manifest. This work will continue to evolve in Longhorn, and it's actually called the application manifest. And so in there, I describe the files that are required, the versions of the files, the dependencies I have in the system, the configuration. And in addition, I have the management attributes of my system. I can define the settings and configuration, health and instrumentation, and tasks that are part of my manifest. This manifest maps to an SDM document. It is a specific syntax for Longhorn for the SDM, tailored to applications. And so it is an SDM system. Operators get to manage systems using they can use traditional management tools, remote local management tools, and the new tools that can be part of Longhorn, that look at these, inspect this information, and use them to expose the management capabilities of your application. And of course, there's a feedback loop here where this is definitely a process where these can continually are refined as you learn more about your application, and so you can change the management capabilities of your system or of your application as time moves on. Let me talk about each of these. I'll kind of outline the effort that's going on into each of these areas. I'll start with settings and configuration. So, of course, this is very critical. Configuration is very critical for any management system. And in today's world, there's a lot of problems. We have a lot of fragility in terms of making changes in a system. There are multiple stores, registry, ini files, etc. One problem that we hear a lot is that it's really hard to tell what are all the settings that belong to a certain application. I mean, certainly I can open a registry editor today, and if the applications follow certain guidelines, I can probably find most of the settings. But I don't have a clear, concise definition of all the settings that belong to a certain application. And more than that, even if I did find the settings, it's really hard for me to tell you what the valid values are for changes that I make. If I change this value from a 1 to a 4, right, is the app going to break? Is it going to? I don't know. And so scenarios such as migration, roaming, and backup become effectively hard, really hard. And And if they're done, they're usually done in a very application-specific way. There's no common services for doing these things. And so you end up with a pretty fragile world. Making changes is usually is perceived as very, very scary. And so in the Longhorn timeframe, we're actually thinking about how to improve the setting infrastructure. And again, there's a new setting infrastructure or improved setting infrastructure where applications can declare their settings as part of their manifest. They declare the different settings that they have, or they can actually do it in managed code by using the attribution model. They can define the settings. They can annotate them with things like, oh, this is a user setting, this is an application setting, this is a setting that needs to be roamed, this is a setting that needs to be backed up, this is a setting that doesn't apply in this certain context. They can define the semantics of the different settings that they have. They can say the valid value ranges, any assertions that they have. This can only be read after midnight. You know, all those semantics are captured in terms of settings. And by doing that, by declaring my settings in this participatory model, well, the system takes care of the rest. There are standard APIs for changing settings. There are standard tools for doing upgrade of these settings, history, consistency checks, isolation, validation. All of that is taken care of by the new infrastructure. And the management tools will leverage this infrastructure when they're actually making these setting changes. So the other part to writing a good manageable application is exposing good instrumentation and defining what it means for the app to be healthy or unhealthy, or the different states of being healthy and healthy. Today, for the most part, health is determined by the operators based on their experience. I know that I've seen a certain event in the event log, and I know it's bad. I don't know how, but it's usually a bad thing. Again, same problem exists here. I can't really go to a single place and tell you what are all the events and all the instrumentation, all the performance counters, and all the things that are raised by a certain application. It's really hard for me to discover such information and tie it back to the application identity. And again, the infrastructure here can use a lot of improvements. And so in the Longhorn timeframe, we're actually thinking a lot about how to improve the infrastructure and how to use this declarative model and participatory model to have every application define the instrumentation that it raises. Here are the events that I have, here are the performance counters that I have, here are their identities, here's what they mean. In addition, we want to capture user guidance, verification, and corrective actions, as well as feedback, all related to this instrumentation. And more than that, we're going to let the application developers who are intimately familiar with the application define what it means for an application to be healthy or unhealthy. And they do that in terms of the instrumentation that is exposed by the application. If the application developer knows that a certain performance counter going above a certain threshold is badness, well, they can define a state called unhealthy state. And they can define it in terms of the instrumentation. If performance counter is greater than blah, then I'm in the unhealthy state. And they can provide a set of actions, corrective actions to the operators. The other thing that we're doing in Longhorn is that we're effectively making monitoring ubiquitous. We're adding a monitoring service in the Longhorn box. So there'll be a monitoring service as part and parcel of the Windows system. That could be used both at a node, getting events and collecting instrumentation and running corrective action rules, etc. on a node, but also can be set up as a distributed monitoring system, collecting things from multiple nodes. And this monitoring service will certainly support all the MOM management packs and all the work that's gone into EIF. And so all those investments in MOM and EIF will continue to be preserved. So the last part that we're doing in terms of improving manageable application is tasks. And tasks are these actions that operators perform. So when an operator wants to back up a database, that's really considered a task. It's an action. It's an operation. We talked about health and instrumentation, which is really about monitoring, knowing when something is healthy or not. We talked about settings, which is about configuration. Well, the last part is really actions, things that I want to do on an application or on multiple applications. Today, there are multiple ways I can do this. There's definitely lots of GUI in terms of MMC and stuff where I can actually perform a lot of actions. And for the most part, you find a lot of resource-centric command line tools. I can configure a lot of the DHCP servers, a lot of the network servers using a nice command line tool today. The problem with all of that is that there's actually no separation, whether it's command line or GUI, from the presentation of a task and the actual task that's happening underneath. To do that, well, I'd have to be a developer. I'd have to think about the APIs that are called by underneath these tools to actually perform the action. And those are at a very low level. So if I wanted to join a domain, well, I have two choices today. I can go into my computer properties dialog box and then join a domain from there. Or I can actually, using the programmatic interfaces to AD, join a domain. And there's typically 3 APIs for me to actually perform that task. There is no UI or presentation independent high-level task to join a domain that operators can use. And so there's a lot of work that's going into Longhorn as well in terms of improving tasks. There's a new shell that replaces command.oxy and allows you to actually, in a very nice way, exposes a language that allows you to specify high-level tasks. There's again, the participatory model. Applications can expose their tasks using the .NET attribution model. They can mark any method in managed code, for example, and say this is a task, or this is a command, and here are its parameters, and here's how it ties in. And by doing that, they tie into the task infrastructure, the task model that we have. The shell automatically can support this. I can pipe different commands from one to another. I have a common presentation tier, a common layer to do this. And a lot of our UI and a lot of our command line tools will be based on top of this model. And they're abstracted enough that it's not, these tasks are designed for operators. They're not designed for developers. They all are very string friendly. They support all sorts of things that operators are used to. And lastly, there's a methodology for what it means to author proper tasks. We can't have people go call this delete, call that kill, call that remove, and all have the same meanings. And so we actually developed a set of guidelines. And again, part of our design for operations, I have a white paper that I can point to at the end. In terms of what it means to author common tasks and have common semantics across them. And so we see here that this is a small example based on a model where there's a verb and then there's a noun and there's a context. So I create a website on a web server. Well, this common model will be shared across all applications that are building these tasks. And of course, we're going a long way into making sure that Windows is completely based on this task model, so you can do all the things that you want to do in terms of management on the Windows box in terms of this simple task model. Just briefly, I'm going to I talked about a bottoms-up approach. I want to touch a little on some of the core infrastructure that is happening also at the bottom in our approach from a bottom-up. And I talked a number of times about the dynamic data center. Again, this is a set of storage firewalls, the storage network, and server resources that are brought in a prescriptive network architecture that we could use to actually make dynamic decisions about load and allocation based on the SDM model. There's definitely broad server support for this, and we're working with a bunch of people on making sure we have the right support and hardware for this. There was a demo of this in last WinHack, and there's a white paper that I'll point you to at the end for more information on this. Automated deployment services is the feature that we shipped in Windows 2003 that lets me take a bare box and deploy pretty quickly an image of Windows on it. Lets me multicast fan out to a set of machines. So think the scenario is I roll in a rack with 500 machines on the rack, and I hit a button and I automatically deploy to the 500 machines an image of Windows, and I can, using a central controller, I can fan out these images. I can control when they're deployed. I can programmatically tailor the images and install applications and do all those things from a central place. So basically it allows you to pretty easily manage a set of machines in terms of deploying them and managing them from a central common location. And then the other piece that went into Windows 2003 that is again on the DSI roadmap is the virtual server piece. I'm sure a lot of you know that this is our Microsoft's virtual machine approach, and the scenarios there have mostly been in terms of consolidation of servers and NT4 migration, but this thing has been really popular with dev and test environments as well. It's used all over in Microsoft, and it now supports the bits we gave out in the PDC support Longhorn, so it's a really common scenario for you to boot up Longhorn in a virtual machine when you don't want to actually install it on a box. And again, this is an important piece, and we're thinking really hard on how to integrate this with our automated deployment services and enable a number of scenarios in terms of virtualization of the hardware and tie it all back to the system perspective in SDM. And this is kind of the roadmap that we're on. SMS 2003 was released in 2000. It's kind of broken up into management, server apps, and dev tool, and Windows Server. And so, Windows 2003 and ADS was released. Microsoft Virtual Server is about to be released, and then the new and then Longhorn and Dynamic Data Center are in that wave. And on the server app tools, we'll see Visual Studio Whidbey is the first release that supports the SDM. I'm sorry, Visual Studio Whidbey, which is in 2005, is the first release that supports that. And we'll continue to see more work in terms of SDM support and system-level development tools. And in terms of management solutions, SMS and MOM, next version of MOM, moving on to the System Center release, which is will completely be enable system-level management using the SDM. And so in summary, DSI is our initiative to actually reducing the complexity across the entire lifecycle of systems, whether it's the development, the deployment, and the management of these systems. And SDM is what we use to define these systems, and it's a document that's persistent throughout the life of the system, allows us to enable such rich scenarios for management and it gives us an end-to-end solution to reduce the cost of these systems. And I talked a little about how our effort around managing applications, building better managed applications that are part of larger systems, and all the good work that's happening in Longhorn to improve the manageability of these applications. There are 4 white papers here. One is on DSI, we just released as part of the PDC. I highly encourage you to read that to get more information on DSI. There's a Design for Operations white paper, and one on the Dynamic Data Center, and one on the Service Orchestration Designer. That's the white horse piece that I mentioned. There's a white paper on that as well. These are all links. I'm sure you get copies of this slide deck at the end. I'm hoping you do. If not, just come see me and I'll point you to these or send me an email. With that, I'll open up to questions. We have about 10 minutes.
So what's the difference between a task and a batch file? Or a shell script?
That's a good question. So the if you will, the new batch file model is you write tasks using the new shell language in Longhorn. Right? Tasks are, in a way, composed of smaller tasks. The smallest tasks they call commands. I didn't go into this much detail, but commands are the things that are exposed by application. They're the atomic tasks, if you will. Right? So you can have a command that's called a backup on a database application might expose a backup verb, right? Command. And so by doing so, then I can write a shell script, right? Using the new language that calls backup and then gets the results of it and does something else.
So if I write my batch file in XML, then it's a task?
No, I don't.
Assuming your new language is XML-based.
No, it's not XML-based.
No, okay.
It's not XML-based. Think of it as a hybrid between Perl and CLR.
Okay.
Right? It's actually a very well-designed language in terms of making it very easy for operators to do things. I don't have all the details there. No, it's not. I know it's definitely not borrowed from Unix. I know there's a lot of very interesting things that are very different from Unix that they're doing there. I can point you to the right person to ask the questions, and I don't know if he's talking in the SAF or not, but they had a very successful session at the PDC in terms of showing the power of the code name for it is Monad, and so if you want, I'll point you to the person you can ask more questions to.
How does this all relate to some of the industry standards like SPML, and there's another one that just came out, which I cannot remember the name of. It's basically another markup language that describes data centers. Maybe you know the name. I'm just not
DCML? Is this the ops work?
DCML, yes.
Right. I'm not familiar with the SPML though, so I don't.
Positioning markup language. That's more for web services.
Okay.
But, DCML is probably.
So it's really hard for me to talk about DCML at this point because I really haven't seen anything on it besides, the press releases.
But Microsoft is not
Right.
anything with that standard right now.
Well, we've been talking to them. I don't know what all the details are. I can point you to the right person that's been doing this talking to them, but I don't know all the details. I've looked at their press releases, and I haven't seen any more details. So until I see more detail, I can't really tell you how they relate.
What is the relationship, if any, between this Monad and the WMI scripting?
That's a good question. So you can think of, the WMI scripting is just VB script, right? This is, if you will, it's another, I don't want to say scripting language because it's not really just scripting. It's kind of a script meets the shell language married together and taking the best features out of all, right? And so this is this is another language, right, for exposing operative-centric tasks and capturing these tasks in terms of what people want to do. You can certainly use that to execute WMI commands, right? And so think of it as, it's an alternative syntax to VB script in that sense, right? Only it's not, VB script is very developer centric, right? You have to know about programming, you have to know about a lot of things. It's not a shell language. It's not an operator-friendly language in a lot of ways. And so Monad is one. Questions?
How does SDM differ from a traditional enterprise architecture to like a PTEC or rational rose in terms of modeling?
I'm not necessarily familiar I'm familiar with rational, but so this is not just a modeling tool. It's not, I know I talked a lot about it's the modeling language, but there's actually, it doesn't go out of the picture when the design is done. It's maintained throughout the system. There's infrastructure. It uses that information to do the deployment, to do the management, to do everything. It's an authoritative document. It's not just a model that I use to frame my design, and then, once I've done the modeling, I've built my system, I'm off on my own. Does that make sense?
Yeah, in part. Is it specific to Microsoft, or do you see yourself embracing a true data set which runs many different operating systems, databases?
That's a very good question. So we're at this point, we're working through the details of the SDM, and we're trying to figure out, what the scope of the SDM and what we're doing there. We're planning to get, we're definitely working with a lot of partners on this, and so this is I work on Windows Server. I'm not going to tell you that I'm using this to build, things for other platforms, but we are definitely working with, like we do with Microsoft. There's going to be a lot of different partners that might help us have a heterogeneous story, work with us on having a heterogeneous story and extending the SDM to have, interop between different systems, different things in your enterprise. We recognize that there's a lot of different heterogeneous, in data centers today are heterogeneous. Everybody recognizes that, and we're definitely not ignoring it. And so, but again, you probably won't see Microsoft do the heterogeneous work. You'll see a partner do the heterogeneous work. Great. Thank you. One more? Okay.
One is the virtual resources. I understand we build on the rest of the acquired connectors, right? But I'm not familiar with connectors. I'm familiar with
Right.
So does it connect a completely new application, operating system, or you just like VMware does?
It's similar to VMware. It doesn't require a new.
Then the next question is about the licensing. So is the licensing going to be changing? Because today if you spawn multiple instances, Microsoft wants to have for every instance
Right.
by license. But now we're going through something dynamically. So maybe I'll just need for let's say scale for 100 web farms just for a couple of days or weeks. So it's
Right.
going to be changing. Or
I am not the person to answer this question, but I will point you to the product manager on this.
for us, HP also.
Okay.
We have similar questions.
Right. So if you want, please come see me. I'll send you the person that can answer this question. I don't know anything about the licensing of VMware. Or one more?
I can use this, or you could use this as a way to, one of the problems you have in pre-deployment is, and doing different architecture curves, for possibly different customers, you can track, your configurations and your costs associated with that, both from the licensing perspective as well as
Right.
from the hardware perspective. And I was wondering if a thought behind putting this tool, if you will, some sort of a cost management.
That's a great question. So you heard me mention how the SDM is a skeleton or the basic structure of a system, and how there could be other information that could be layered on top of this. This would be a great application of the SDM, right? So you can certainly say that you're going to use that to track things. Again, I represent the Windows Server perspective, and I'm responsible for the SDM service and SDM model, and so. I'm not necessarily directly responsible for thinking about all the different applications of the SDM, and I don't know if any of the folks in the management space in Windows or Windows are you thinking of those along those lines. But we certainly encourage if you guys are system vendors or ISVs to think about how to use that, and we're happy to entertain these discussions. But so the evolution of SMS is called System Center. You'll see SMS and MOM merge into a product called System Center. System Center is going, if you will, is completely built on top of the infrastructure that's in Windows. That's both from a monitoring perspective, from terms of SDM, everything else. We're working very closely with the Enterprise Management Division in Microsoft to make sure that we have an integrated product there, that they can use the infrastructure we're building to do the management and enable system level management. Immediately, I don't know of anything special that SMS is doing to take care of this or take advantage of this infrastructure. Right, so there's definitely a lot of thinking in terms of having discovery and validation services that can sniff out the real world and try to match it with what's in the SDM. And yes, that would be a great example of it. Great. One more? A system tier as what single tier? Is that what you said? Right. As in, is it distributable?
Is all the monitoring and all that kind of stuff run off of a single host or a single cluster host, and then goes out and fields the network?
I don't know the answer to that. I know they're thinking about having distributing the central. I know the monitoring service folks are thinking about distributing it. I don't know what their plans for the immediate release coming out, but I can point you to the person if you want to know. Well, again, the monitoring service will be part of Windows, and so I don't know. It's not. Yeah. Great. Thank you so much.